Welcome everybody. So we're gonna find the equation of tangent line to the curve given by the equation y squared equals 5x to the fourth minus x squared at the point 1, 2. Okay, we're gonna use implicit differentiation since this is not exactly an explicit equation, and it's actually gonna be easier to do that, to do implicit differentiation. So we're gonna figure out dy over dx. So we're doing derivative of both sides with respect to x. So derivative of y squared gives us 2y times dy over dx. On the right hand side we end up having 5 times 4x cubed minus 2x. So simplify it a little bit. We can go through and divide by 2. So we have y times dy over dx equals 10x cubed minus x. Then divide both sides by y, and we have the formula for the derivative. So dy over dx is equal to 10x cubed minus x divided by y. So now we can check that the point 1, 2 is on the curve. So plug in y equals 2, x equals 1. We're looking at 4 being equal to 5 minus 1, which is the correct statement. Okay, so now we can find the slope of tangent line. So the slope is dy over dx, and we're going to plug in x equals 1 and y equals 2. So that gives us 10 times 1 cubed minus 1 divided by 2. So that is 9 divided by 2. And then equation of tangent line will be y minus 2 equals 9 halves times x minus 1. Or if we add 2 to both sides, it's going to be y equals 9 halves times x minus 1 plus 2. So that's the equation of tangent line to this curve. Now in this video clip we're going to find equation of tangent line to the curve defined by this equation at the point 3, 1. So we start by checking that 3, 1 actually works in the equation. So plug in x equals 3, y equals 1. We get this expression simplified, and we get that 200 is equal to 200. So yes, the point 3, 1 is on the curve defined by this equation. And we then proceed by finding dy over dx, as that will give us the slope of the tangent line. So we're going to do derivative with respect to x of left hand side should be equal to derivative with respect to x of the right hand side. And as a side calculation, we can find those two derivatives. So derivative with respect to x of 2 times x squared plus y squared squared. We can factor out 2, so doing derivative with respect to x of the square of the x squared plus y squared. So by the chain rule, this is derivative of something squared, that's like u squared. We have 2 times x squared plus y squared, that's 2u, multiplied by the derivative of u. Okay. So we have 4 times x squared plus y squared multiplied by derivative of x squared plus derivative of y squared. So we have 4 times x squared plus y squared multiplied by 2x, which is derivative of x squared, plus 2y times dy over dx. So we use implicit derivative on y squared. And if we distribute the 2x plus 2y times dy over dx, we get 4 times x squared plus y squared times 2x plus 4 times x squared plus y squared times 2y times dy over dx. So that's what comes out of the derivative of left hand side. And well, so if we multiply 4 by 2, we get 8. So this is a slightly simplified form of that derivative. Now for the derivative of right hand side, we can factor 25 out of the derivative. And then we're just doing derivative of x squared minus the derivative of y squared, which ends up being 25 times 2x minus 2y times dy over dx. Distribute 25, and we have this simple form, 50x minus 50y times dy over dx. So going back to what we were trying to accomplish, So derivative of left-hand side is this expression. Derivative of right-hand side is that expression. So we have left-hand side equals right-hand side. So now we're going to move the dy over dx term from the right to the left, and this clean term from the left to the right, so that we have this version of the equation. So we have 8y times x squared plus y squared times dy over dx plus 50y times dy over dx equals 50x minus 8x times x squared plus y squared. And so we can go ahead and divide through by 2. Then factor out dy over dx on the left-hand side and divide by the long expression we have next to dy over dx. So that's the formula for the dy over dx, and we use it to find the slope of tangent line. Just gonna take this formula and then plug in x equals 3 and y equals 1. Do some arithmetics, reduce it, and we have that the slope is negative 9 over 13. Okay, great. So now we're ready to get the equation of tangent line. So it's going to be y minus 1 equals negative 9 over 13 times x minus 3. So if we add 1 to both sides, we have this solved for y equation. Y equals negative 9 over 13 times x minus 3 plus 1.